In this section, we'll subtract fractions and mixed numbers. To subtract fractions, if the denominators are not the same, find the least common denominator. Change each fraction not expressed in terms of the common denominator to an equivalent fraction with the common denominator. Then subtract the numerators. The common denominator will be the denominator of the difference and reduce the difference to lowest terms. These are pretty much exactly the same rules that we use for adding fractions. We're just subtracting instead. Gets a little more complicated when we're dealing with mixed numbers. So for our example, we'll subtract 7/32 from 3/8. So the first thing we're going to have to do is change this to a common denominator. We know that the common denominator of 8 and 32 is 32. So we just have to multiply 3/8 by 4/4. So that's going to give us 12/32 minus 7/32 is 5/32. And that's the answer. To subtract mixed numbers. This is a much longer plan here, and it'll take us longer to go through, but ultimately it's not that difficult. To subtract mixed numbers, first, if the fractional parts of the mixed numbers do not have the same denominator, change them to the equivalent fractions with a common denominator. When the fraction in the minuend, that's the number that we're subtracting from, the number that we're subtracting from, is larger than the fraction in the subtrahend, the number we're subtracting, go to step 6. When the fraction in the subtrahend is larger than the fraction in the minuend, regroup, borrow, by taking one whole number from the whole number part of the minuend. This makes the whole number one less. Change the whole number that was borrowed to an improper fraction with the common denominator. So for example, 1 is equal to n over n, where n is the common denominator. Then we add the borrowed fraction, n over n, to the fraction already in the minuend. And we subtract the fractional parts and the whole number parts. And then reduce the difference to lowest terms. So in this first problem, first we're going to change our 1/2 to 8ths. So we need to multiply that by 4/4. That's 15 7/8 minus 4 4/8. Then we can subtract the whole number parts. So 15 minus 4 is 11, and subtract the fraction parts. 7 minus 4 is 3/8, and we're done. For these others, we're going to have to do, well, for the second one, for B, we're going to have to do a bit more work, because the fraction in our subtrahend, 15 3/4, is larger than the fraction in our minuend. Let's change this to fourths, and we can see that pretty quickly. That's 18 2/4 minus 15 3/4. So we'll borrow 1 from our 18, we'll make that 17, and then that becomes 2/4 plus 4/4 is 6/4. And then we'll subtract 15 3/4 from that. So then we've got 17 minus 15 is 2, 6/4 minus 3/4 is 3/4. And there's the solution to that one. Finally, we have 45 1/3 minus 27. Well, 27 has no fraction part, so we can just subtract the whole number parts, and the fractional part is going to stay the same. 45 minus 27 is 18 1/3. And we've got a few other example problems. First, 127 1/2 pounds of sugar is used from an inventory of 433 and 5/8 pounds. I think that might be 3/8 pounds. Not that it really matters for our purposes. We'll just say it's 5/8. How many pounds of sugar remain in inventory? So if we take 433 and 3/8, whichever, minus 127 and a half, we need to change our 3/8 and our half to the same terms. That means we want the lowest common denominator, which is 8. So this is 433 and 3/8 minus 127 and 4/8. Now notice that 3/8 is less than 4/8. So I have to subtract 1 from my 433 to get a 432. And then I'll add 4/8 to my 3/8 to get 7/8. Minus 127 and 4/8. Now I can subtract my whole number parts. 432 minus 127 is 305. And 7/8 minus 4/8 is 3/8. I'm sorry, that shouldn't have been 7/8. It should have been 11/8. One second, I'm sorry. Yes, it should have been 11/8. 11 minus 4 is 7/8. There we go, that's better. 305 and 7/8 is our answer. For this next problem, how many feet of coaxial cable are left on a 100-foot roll if 27 1/4 feet are used from the roll? So we've got 100 minus 27 1/4. So we need to take one of my 100, that's 99, and then we'll add the one that we took away as 4/4. So that's 99 and 4/4, which is exactly the same as 100, minus 27 and 1/4. We subtract, and I should say that's pounds of sugar. Remain. We should always write the answer to our word problems. Okay, so here we've got 99 and 4/4 minus 27 and 1/4. 99 minus 27, that is 72. 4/4 minus 1/4 is 3/4. So the answer here is 72 and 3/4 feet of coaxial cable are left. Finally, we're asked to perform the indicated operations, and this is a problem where we have both addition and subtraction. So the first thing we're going to do is we are going to treat this, we're going to deal with the first two parts of this as an addition problem, and then we'll subtract, but I'm also going to put everything into the least common terms right away. We've got a denominator of 3, 2, and 5, and the least common denominator is going to be 30. So that's going to be 5 and 20/30 plus 1 and 15/30 minus 3 and 12/30. So first we'll add these two together. That's not going to be too hard. That's going to be 5 and 20/30 plus 1 and 15/30. And I'm just going to leave the mixed number here with an improper fraction because we're going to be subtracting anyway. So that's 6 and 35/30 minus 3 and 12/30. 6 minus 3 is 3. 35 minus 12 is 23. The answer is 3 and 23/30. And that's just it. We can't simplify that any. Of course, it would help if you could see that last line there. Here it is. All right.